Now coming to many-to-one relationships, uh, just like the previous case where we used one-to-one relationship, even in many-to-one relationship, the maximum number of tables needed will be three. For example, let us take the table entity A1 is the primary key. So let me take four records. Then for entity B, let me take another four records. And the relationship R, since it's only a partial participation, few records of A are shown in the relationship. Okay. So now here I used three tables, one for A, one for B, and one for R. Now can we minimize the number of tables? Yes. So which side should we shift the relationship? Should we shift it towards A or should we shift it towards B? We can see that shifting towards A will be the right uh, way of doing it. For example, if I merge A and R into one table called the AR table, it will be the best way. Why is it the best way? Because we can see here in the relationship table, only records from A are not repeated, whereas the records from B are, I mean, the values from B are repetitive. 101 and 101 are repeated twice. But from A, they are always unique. So it will be easy for us to shift R towards the many side. So whichever is the many side, it is towards that side we should shift that relationship. So since the many is towards A, best is to shift R towards A because as I mentioned once again that A1 is not repeating, whereas B1 there are repeating. So A1, A2 and B1. So I'll put 1, 2, 3 and 4, A, B, C and C. Whereas B is 101, 102, 101 and null. It is not possible to shift R towards B because there will be no record, it is not unique in the relationships. So it is not possible to shift R towards B. It is only possible towards shift towards A. So whenever there is a many to one relationship or even one to many, you should always shift R towards the many side. So in the one to many case, what will happen? We'll shift R towards B. Whereas in the many to one, we have shifted R towards A. So we form two tables. One is the AR table, where A1 is the primary key, and the B table, where B1 is the primary. Whereas in the second case, A will create a table for A and another table to combine R and B and R, forming BRT. So always is the rule of thumb that we'll always shift the relationship towards the many side. In case of many to one or one to many, we'll shift it towards the many side. Now what if there is a total participation from the side of A? If there's a total participation from the side of A, for example, even let me assume that record 4 is also mapped to 101. So what will happen in the AR table, B1 can never be null. Just like in the one-to-one relationship, we have discussed this. So same thing will happen here. B1 can never be null. So when there is a total participation, then we have to mention that B1, for B1 we have to put a constraint that not null. So that's the only additional change that has to be done. So whichever side there is a total participation, that side we have to put a constraint that it is not null. Now coming to the many-to-many relationship, again we'll take the same example. Since let us take the relationship R. So we can see that it's a many-to-many mapping. Like there are many records of A and B which are mapped to each other. So it's a many-to-many mapping. In this case, it is not possible to minimize the number of tables. So we can only have three tables in this case. So in summary, let me summarize everything. Uh, Suppose we have sorry, suppose we have uh, a one-to-one relationship between A and B. Then we can shift the relationship R either towards A or towards B. So what are the optimum number of tables needed here? Optimum tables are optimum number of tables are optimum number of tables are only two. So what are the tables? Either AR table with attributes A1, A2 and B1 and the B table. The attributes B1 and B2, or the A table with attributes A1 and A2 and the BR table with the attributes B1, B2 and A1. Now, whichever side there is a total participation, towards that, in case if there is a total participation, then we have to put an additional constraint that the B1 cannot be null. This we have already explained in the last video, that whichever side there is a total participation, we can only put not null. So in case if the relationship is complete on both the sides, then how many tables are needed? There will be only how many tables will be needed? Only one table will be needed. What is the table? It's a combination of A, R, and B, where either we can take A1 as the primary key or B1 as the primary key. Either of them we can take as a primary, either this one or this one. Now, in case of many to one or one to many relationship, many to one or one to many relationships, what we have to do? We have to shift the relationship in order to optimize the number of tables. Sorry, in order to optimize the number of tables, we have to shift uh, the relationship towards the many side. So in this case, where is the many side? It is towards A. So I will shift it towards A. So again, the number of tables needed are two. One is AR and attributes are A1, A2 and B1. Then the table B with attributes B1 and B2. So whichever side is the many, that is the side we will shift the relationship, thereby reducing the number of tables. And in case we have many to many on both the sides, many to many on both sides, then what is the only option we are left with? We have to have we have to have minimum three tables are needed. One for A, one for B, and one for R. So minimum there will be three tables needed. We cannot reduce the number of tables beyond three. So we have to use three tables, one for R, one for B, and one for A. So this is the number of optimum number of tables that are needed for different types of relationships.